Hello, judge and organizer. My name is Irene, and I will be presenting behalf of our team. And let me introduce you to our proposal, which is called GUARD. It stands for Geohazard Unified Autonomous Remote Detection. It is a continuous volcanic monitoring and dual-phase emergency response system. So, before we dive more deeply into our proposal, let me introduce myself and my other team member. Hello, my name is Irene Belisha Aldunijayanto. I'm a third-year undergraduate student in Universitas Gadjah Mada and majoring in physics engineering.
I am Fatia Khalida, a third-year undergraduate student in Universitas Gadjah Mada, majoring in electronics and instrumentation.
Hi, I am Nafis Ilayaswati, a third-year undergraduate student in Universitas Gadjah Mada, majoring in electronics and instrumentation. What happens when the world's most volcanically active nation cannot continuously watch all of its volcanoes? That is Indonesia's reality right now. As we can see on this slide that according to USGS in 2024, Indonesia is the world's most volcanically active nation and also has the greatest at-risk population for volcanic hazards. Meanwhile, according to Indonesia's Geological Agency in 2025, Indonesia has 127 active volcanoes. This means volcano monitoring in Indonesia is not just a scientific task but also a national priority. And the impact is deeply human. According to BNPB, volcanic eruption in Indonesia affected around 650,000 people between 2010 and 2023. This massive number shows that volcanic disasters are not isolated events, but also recurring threats to human safety and community resilience. The challenge becomes even more urgent because a study by Mukti and friends in 2022 found that about 41% of Indonesia's volcanoes still lack direct real-time monitoring. Moreover, many volcanoes in Indonesia are located in remote areas where reliable infrastructures cannot always be guaranteed. According to Antara in 2025, Indonesia still had 5,700 villages and also 4,400 hamlets without electricity access. In these conditions, remote monitoring systems become highly vulnerable to battery dependence. As highlighted by Ma and friends in 2019 and also Kang in 2024, power depletion can trigger shutdowns, data gaps, and also serious operational disruption. In short, when power fails, monitoring also fails. This is why we propose GUARD. GUARD directly aligns with two focus areas: space technology for disaster monitoring and also climate observation and space technology for society. It strengthens continuous volcanic monitoring, improves early warning, and also supports post-disaster response in remote high-risk regions. In addition, GUARD integrates multiple disciplines including aerospace engineering, stochastic geometry, telecommunication, renewable energy, and artificial intelligence, making it a resilient and adaptive disaster mitigation ecosystem for Indonesia.
As what my other team members have mentioned, guard system could be used for both early warning and emergency response. So, how does the system really work? The system works in two phases, which are disaster forecasting warning as the first phase and emergency response as the second phase. In the first phase, UAV will fly in a certain path because we have embedded certain algorithm using stochastic geometry. UAV also has a backscatter reader which will read the reflected signal from the passive sensor. The system will collect data until UAV get back to the microgrid station. So, the station uses microgrid technology to ensure a stable and continuous power supply, especially because the system is deployed in a remote volcanic area. At the same time, it also acts as a central hub for data storage and processing, where the collected data is analyzed to detect early signs of volcanic activity and trigger evacuation warnings if it's necessary. Then, when disaster actually occurs, the system transitions into the second phase, which is emergency response. In this phase, the UAV switch to SIR mode or safe and rescue mode and works together with Doppler radar sensor. Unlike the passive backscatter sensor, Doppler radar can detect motion, so it is used to identify survivor, debris movement, or other dynamic changes, even in low visibility like ice or smoke. Overall, the system is designed as a multi-layered and redundant architecture. So even if one part of the system fails due to extreme condition, the other component can still maintain partial functionality. This makes the guard system more reliable, for both early warning and post-disaster rescue operation.
Okay, so let me walk you through how we plan to bring work to life. Our implementation is structured across 5 phases over 7 years. We start with R&D and system design in year 1, building prototypes and coordinating with PVMBG, BRIN, and local BPBD. In years 2 to 3, we move into full production and integration of all components. Year 3 to 4 is our pilot deployment at high priority volcanic sites, where we validate the system against real field conditions. Year 4 to 5 focus on evaluation and refinement, improving our AI models, microgrid efficiency, and UAV routing. And finally, in years 5 to 7, we scale nationally across all 127 active volcanoes in full collaboration with PVMBG, BNPB, and the Ministry of Energy and Mineral Researches. So what the impact does GUARD deliver? There are 5 key areas. First, anomaly detection within 2 hours gives authorities a minimum 46-hour evacuation window, directly saving lives in volcanic risk zones. Second, GUARD can be replicated across all 127 active volcanoes, bridging the monitoring gap from 59% to our full national coverage. Third, our self-sustaining microgrid ensures 24/7 continuous operation without any dependence on the national power grid, aligned with RPJPN 2025 until 2045. Fourth, UAV is equipped with Doppler radar, significantly strengthened post-disaster search and rescue capabilities. And the last, QUAD directly contributes to SDG 9, 11, and 30, aligning with Indonesia's global sustainability commitments. So to wrap up, Indonesia still faces critical and structural gaps in volcanic monitoring, especially in remote and off-grid areas. QUAD addresses this with one unified system: passive backscatter sensing, autonomous UAVs, AI-driven anomaly detection, Doppler radar for search and rescue, and a self-sustaining renewable microgrid. Together, these technologies enable faster, early warnings, broader disaster protection, and stronger emergency response for vulnerable communities across Indonesia. QUAD is not just a monitoring tool, it's a scalable, resilient, and life-oriented innovation designed to protect millions of lives on the path toward Indonesia Emas 2045. Thank you.